We're going to talk about sorting algorithms now. And one sorting algorithm we're going to look at is a selection sort. Okay. Basic idea. What are we trying to do? We're trying to arrange the information contained within the data or the data set in an ascending or descending order. Okay. You could think about it like, maybe it's a dictionary or a phone book, something like that, where you would have things, you want to order things appropriately. Okay. And the reason for that, of course, why do you want to sort things? Well, you sort it so it's easier to do a search later on. Okay. So the only one we're going to look at is the selection sort. All right. And the basic idea of how this one works is if you think about, and I'll show you an example. You're trying to find the minimum value. So let's say you have a list of numbers. So let me go to the example as I talk about it. So here's the example. So let's say I originally have these numbers: 29, 45, 18, 51, and 36. So those are the 5 numbers that I have. Okay. The way this algorithm works, selection sort, what it does is it makes a comparison between these items. It finds the minimum item of this row, finds the minimum item, and it takes that minimum item. So in this case, the 18 is the minimum one. It takes it and swaps it with the first item. Okay. So after your selection sort algorithm runs one time, goes through one iteration, we now have, or our sorting algorithm or function goes through and runs one time, we now have 18 in the first slot, and then the 29, of course, went over here. All right. Now what you do, 18 is in its correct place. It is the smallest one of this whole list. That's in its correct place. So we no longer need to look at it. So now what we do with the remaining part of the list, we look at those numbers and perform the same operation again. So looking at this, you could think about, okay, 45, 29, 51, and 36. The smallest one in this whole list is the 29. So 29 gets swapped with the first number here, 45. And there it is. Okay. So now what we know, this item is in the correct place. This item is in the correct place. And now what we're going to do is just do the same operation on the rest of the numbers in the list. So we perform the same operations again. And what we find is the 36 is the smallest of these. So the 36 gets swapped with the 45. Okay. And now you see, here's 36. So we have 18, 29, 36. And the last time we're just going to look at these two and make a comparison. And if this one's smaller than this one, we swap them. So you're going to see it get swapped one more time. So that's the basic algorithm. Okay. So just step back, previous page. So what do? You find the minimum place it in the first position. Find the next minimum value, place it in the second position. So you keep doing this until you have placed the second to the largest value and the second to the last position. Then you're done, because of course the last one is going to be the last number it's only by itself, so it'll be in the correct place. Okay, so basically you start this algorithm, you go all the way up until you get one less than the end. Okay, so just going through here. And what we'll do is we'll look at some code. Okay, I opened up a project and I just called it selection, chapter 7 underscore selection sort. So this is on the desktop. I just spent the time coding up the sort function. The sort function's on page 375 and 376 in the textbook. And this is a selection sort function. So what I'll do is I'll just talk about this briefly and kind of relate it back to the algorithm that I had gone through. Okay. So this is very much, remember we did that like find minimum function previously, where it basically was this. It's this for loop. The find minimum was basically this for loop. Where it went through a list of numbers. In this case, it's going through making comparisons, and it keeps like the index of the minimum value. Okay. So after this goes through, like it gets all the way through to the end, you swap the current value, okay, which was the M, which is like the first item in the list. This this M represents that location. So it starts off at 0, goes to 1, goes to 2, 3, 4, as we go through the list of numbers, okay? So it always gives you like, this is the value that it gives you like the current first item of, let's say, sublist, right? So this always, the M is going to contain, M will contain that. M is current first item of sublist, okay? So at first the list is an entire list, so M starts off at 0. The next time this goes through the loop, next time it goes through this entirely, or next time it goes through this for loop, M now takes on the new value of K, all right? So, and what this does, the code down here, all it does is this thing called hold is just a temporary storage, okay? This is the actual code that swaps the values contained at the smallest value, swap the values, swap the smallest value with first item of sublist, okay? So you have to have this temporary variable. Otherwise, if you don't have that temporary variable, of course, once you write one into the other location, then you would overwrite it, right? And you wouldn't have that value anymore. So the first one you do is you take that smallest value there. M is equal to J. Oh, so M contains the smallest value at this point. Okay, so M will contain the smallest one. All right. So let me write this a little bit differently. K is current first item. Okay. Right. All right. So M keeps track of the smallest item. All right. So here you're going to take the smallest one and you put it into hold. Then you take the value at K, which is your first item in your sublist, and you put that into M, the smallest value. And then you take hold and put it into K. So this does the swapping, all right? And then you go through it. You start at 0, and you go all the way through till you're N minus 2. So you're going like one less than the end, all right? And the reason it's N minus 2 as opposed to like N minus 1 is because, remember, we always start at 0 when we're dealing with arrays, okay? And like I said, this is what goes through, this is the loop, and I'll say this, loop to find min value of a list, okay? Which gets smaller and smaller each time we go through it, all right? So this is the sort function. And like I said, I took it directly from the textbook, so it shouldn't be too bad to get that. Okay, so now what we're going to do, what we need to do is create an array and put some numbers in it. And I'll just call this one AR. And I'll leave it like that. And it doesn't really matter how big. I'll just say 2.3, 3.5. I'll put 5 numbers in. 1.3, 2.7, 6.2. Okay, there we go. And then what I'm going to do is, oh, sorry, I'm going to make it equals to that, equals. Then what I'm going to do is I'm going to make a call to this function, sort, and I'm going to pass in my array, and, which is this number. Then the second number, n, is the actual size. So this is 5. Okay. And then what I'm going to do, I'm just going to do a cout. Oh, you know what I'll do? 4. I'm going to say 4 integer I equal to 0 to I less than or equal to 5. We'll just hard code it in for now, but that's the number of items in the list is, less than 5, I plus plus. And then what we'll do is we'll just do cout AAR I. And then I'll do an inline, so you'll see it in the list. It'll be in order. Okay. So this just display the array sorted, right? If it works right, it's going to now display this in sorted. Okay, so let me do a file, save all, and run it. And I forgot to put in my system pause. I'll put in system pause, make it easier. Okay, let me run it again. Okay, 1.3, 2.3, 2.7, 3.5, and 6. Let's see, I'll make this bigger font. Okay, 1.3, 2.3, 2.7, 3.5, and 6.2. Okay, and now it's in order. So there's the code. This is the actual algorithm, right? This is the selection sort. So I'll put this in here. Selection sort function. Okay? All right. So that implements that algorithm. Okay, so there's the entire program. So if you wanted to pause it and see it and then recreate this. But this is essentially all this is what I got directly from the textbook, and then the little part here I just added in. Set the array, make a function call. Remember, this is called by reference when you make a call like this with the array name, then the size. What it's going to do is it's just going to it'll display this. This just displays the sorted array. Okay, and that's about it for selection sort. Okay, now I'm going to talk about search algorithms. There's actually 3 of them that we're going to look at. The first one is searching an unordered list. Okay, this is a so-called simple or sequential search. All right, and basically you just keep searching for an item, examine each element starting with the first one until you find the item. Okay, or you get to the end of the list, which basically says you didn't find it. All right. So you can implement this. You could just do it as a function which returns true if an item is in the list, false if it's not. Okay. You could also do it with like a function which returns the location of the item if it's found and a -1 if not. Okay. All right. So we'll take a look at the code for this, and then we'll modify it so if the list is sorted. Okay. Okay, I just took in on page 377, page 377, I just added this function into the code I already had, right? The other the sort function, the sort code, the sort program that I wrote. So here's the sort function still there. So I just put this between main and that sort function. Okay, so it's still the same code. And this is basically how this works. You pass in the array. You pass in the size of the array. And then you pass in the value that you're searching for. Okay? And this one, this is like, I took it exactly from the textbook. What the index for is basically this just starts us at 0. You could use a for loop if you wanted to, but the author chose to do this, so we'll follow this. Okay. So as long as the index is less than n, you're going to keep going through this loop here. So you keep going until less than n. All right? As long as it's less than n, you keep going through. And the value is not, this is not equal to value. All right? So you didn't find a match. So there's 2 possibilities, right? Let's say we put in a value that's not in our list. Okay? So what would happen is this would keep going all the way through because you would never find a match. And then at the end, it would have a value of index that essentially is 1 less than the end. Okay. So if you got all the way to the end, and this one says basically, okay, index is less than end, and this is equal to the value, meaning that, well, what is a little redundant, but that's okay. Meaning that the index was still less than n, and then a was equal to the value. So if a is equal to the value, essentially you're going to return that index. So you found it, right? You return the index of where you found it. That's essentially what this is, okay? If you didn't find it, what's going to happen is that you return a -1, okay? So what we'll do is we'll use this code here. So what I'm doing is I'll make a call to this function. So it's going to be search. And the list is unordered right now, right? I didn't call the sort function yet. The sort function gets called. Oh, wait. I did call it first. Let me cut this out here. Just move it here. So I got to do it before the sort function, right? That's the whole point of this. Okay. So search. I'm going to pass in the array. AAR. I'm going to pass in the size. 5. And I'm going to pass in the value that I'm going to look for. So let's put in 1.3. All right. And then what we're going to do, this should pass back on value. So I'll just say location. How about that? I'll say location equal to this, and I'll say integer location. So it's going to tell me the location in the array. All right. So we're good. Why is that? Oh, it's a constant data type. It's constant over here. So it defined it as constant. So I have to make this constant or change this so it's not constant. So I have a choice. And the reason is you're not supposed to change it. But you know what? I'm just going to do this. I'm going to get rid of the constant there. Okay. And that should correct it. Oh. So I got rid of the constant here. Oh, I see. It's not it's okay. There's a couple of things I forgot here and a couple of errors. I just fixed them. But here we go. Here's my function prototype. So search prototype, right? I need this. Okay. Here's my function call for the search. And what I did is I changed this to double. Okay. I changed it from integer to double. Both places. You got to change it right here also. Okay. Because I made it a double right here. So that way it matches now. All right. So this is the location should find it, and it should return 0, 1, 2. Right? So let's do a cout. Location. Endline. Right? And we'll just do file. Save all. And we'll run it. And there it is. There's -1. So it said it could not find it. Let me see. I thought it didn't find it. So let me take a look here. Okay. So one more things I need to fix, right? I need to make this a double. Okay. So I'm using it. I'm just modifying it just so it supports the double data types. So that's double. Then this has to be double right here. Okay. So that's really the only change from the text. I'm making it double because that's what we set the other one up to be, the sorting to be that. So now I can rerun it. Okay, it found it. Okay. So now we do this simple sequential search. That works out well. The second part of this, what we want to do is we want to actually do a search again, and after we sort it, and then look to find it, right? So let me do this. I'm going to say location equals here instead, and I'll do this. Okay. And I'll say location equals, so before sort, before sort, location equals this. And then I'm going to go down here, control copy. Oh, well, that doesn't really matter. The only other part is that it's the list is sorted. So then it's going to have a new location, right? And I'll say after sort location equal to this. Okay. So what I'm going to do is I'm going to I'll get code from the textbook for the sorted list, and that actually is on page 378. Okay. So I'll pull that one back. Okay. So I went to the textbook, page 378, and now I'll call this one. This is my sorted search, right? Sorted search. So the list is sorted now. Okay. All right. So I had to make it a different name than what it's in the textbook, and I also did this as a double, and this is a double. Okay, I called it sorted search. They call it search, but I can't use that one with this one at the same time, of course, same name. So I had to make that change. All right, now the only difference here, the only change in the code is actually this right here. Okay, and basically, if it's sorted, what happens is that if you get past the value, meaning the value gets larger than the item it's in the list, and that means you didn't find it, right? And it's not in the list. Okay? So at that point, you can stop, right? You don't have to keep looking. So the only real difference between these two is that this one is a little more efficient now, right? Because you don't have to go through the entire list. If it's sorted, then you only have to go to the point where the value that you're looking for is if it gets larger than what it finds in the list, then you know it's gone past that point and it's not contained within the list. Okay? So what I'll do is I'll run this, but I'll do location again equals sorted search. And now, of course, the item is now first, right? It's going to be first in the list. And then it's AAR, comma, 5, comma, 1.3. Okay? All right. And then we run again. And we do after the sort. Okay. And then I'll run this. Okay. So before the sort, it was at location 2. After the sort, it was at location 0. So although you can't see that it's working differently, it is more efficient because now it doesn't have to look through the entire list, all right? It stops because it's sorted, all right? So that's pretty much it. I'll put this code on the website in the source code area so that you can just grab it directly and then take a look at it, okay? Okay, so that was the searching an ordered list. And then there's a binary search. And the binary search I'll cover next time. But the modified sequential search is more efficient than like a standard sequential search if the list is unordered. This is more efficient. And then binary search is actually more efficient than that. Okay, and we'll take a look at binary search with the part 3 of the lecture slides.